Hello, and welcome to an introduction to direct current. My name is Shivam Hingorani, and today I will be helping you understand this new topic. Let's get started. If you're watching this video, you're probably wondering what direct current actually is. Now, this is a very important question since you need to understand what direct current is before you can do anything with it. So let's answer this question. What is direct current? Well, before we can understand what direct current is, maybe it would be better if we just understood what regular current is. Let's look up a definition for current and see what we find. Current is the rate of change flow past a given point in an electric circuit. Now, like me, you may be slightly confused by what that means, so let's try to find a different definition. Here's one. Current is the time rate of flow of electric charge in the direction that a positive moving charge would take, and having magnitude equal to the quantity of charge per unit time. That's also very confusing, so let me simplify it for you. Current is the number of charges passing any given point in a wire divided by the amount of time it took for these charges to pass this point. So if you were looking at one point on the wire and you were counting the number of charges going by that point, you could then divide it by the amount of time it took for those charges to pass, and you would have the current. Now that we know this, we can go back to asking what direct current is. The definition of direct current is actually rather simple and easy to understand. Direct current is simply current that flows in only one direction. So what are some sources of direct current? Well, direct current comes from batteries, power supplies, thermocouples, solar cells, dynamos, and more. And what are some common uses of this direct current? Well, you use direct current every day in your cell phones, TVs, flashlights, refrigerators, and your hybrid and electric cars. As you can probably tell, direct current is extremely important to the things we do every day. Another thing to know about direct current is that the voltage that is sent through direct current stays constant over time. So, as you look at the flow of energy and current through a wire, you will always see that the voltage remains constant. If you don't know what voltage is, that's okay. We'll take a look at this a little later. Now let's take a look at some vocabulary that we need to know to understand direct current. You can see a diagram of a circuit on the right, and this circuit is composed only of a battery, a lamp, and a closed circuit, and a circuit that is closed with wires. Now, one thing you need to know is the source. The source is a device that supplies the signal, power, or electric energy to a load. In the diagram to the right, that's the battery, since the battery contains all the energy that will be sent to the lamp. Another term to know is the load. The load is the electrical component or portion of a circuit that consumes electrical power. This, in the diagram on the right, is the lamp, since the lamp is consuming the power that the battery is sending to it. One more term to know is the load resistance. This is a measure of how quickly energy can flow out of the source, measured in ohms. Finally, the voltage is the difference in electric charge between 2 points. Any 2 points on a circuit will always have an electric charge, and there might be a difference between the two, and this difference is known as the voltage. Knowing this, let's take a look at one of the most important laws in your understanding to direct current. Ohm's law. Ohm's law is the single most important law in your understanding of direct current, and you can tell by the way it pulsates on your screen. So what is Ohm's law? Well, Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. That may not be immediately clear, So let's take a look at the equation for Ohm's law to help us better understand this. The equation is I equals VR. You probably don't know what these variables stand for, so let's take a look. I is the current in amps, V is the voltage in volts, and R is the resistance in ohms. So what Ohm's law says is that the current is directly proportional to the voltage divided by the resistance, or I equals VR, as you see. This is a very simple law to make sense of, so let's take a look at a practice problem so that we can try it out. Calculate the resistance in ohms given the following data. The current is 10 amps, the voltage is 25 volts. We can use Ohm's law, which says I equals VR, and then V over R, and we can rearrange this equation to get that R equals V over I. Then we plug in for what we know, and finally we calculate that the resistance is 2.5 ohms. Congratulations, you've just solved your first Ohm's law problem, and you've used direct current in a practice problem. And with that, you're ready to do more direct current problems. I hope you've enjoyed this video, and I hope you continue to do more direct current problems in the future. Thank you.